Now that I've got over 1,000 subscribers, ad revenue is coming in fast. By the way, thanks to every single one of you for supporting me. And what to do with all the money? There's no better way than to directly lose all of it in the stock market. Since I need to keep track of how much I already have lost, I need that data and I need some fancy graphs to show me the disaster. So let's build a C++ app together that is showing the real data of any stock. We will need 4 components. We will build a web scraper based on curl. We will build a CSV parser that is extracting the data. We will build the inputs to select which stocks to show, and we will build a GUI based on Dear ImGui. Use the chapters below to skip to the sections that interest you most, and other than that, enjoy the ride. We start off by using this Dockerized Dear ImGui framework that I've presented in one of the last videos. It offers a simple app framework that we can extend on. I have already cloned the framework here, and I have already extracted it and built it, and am on the main branch, so we can start adding here the changes to this default app. Let's firstly build the default app and show how it looks like. So we go here to the console, and then we use the build command to actually generate here the build files. And afterwards we can run the application by using here the run. And we see we have here this Dear ImGui demo inside with all of the different stuff that we might be interested in. But other than that, there's no real content. So first things first, we need to gather the dependency for the curl web scraper. Curl, or CURL as some say, is basically a tool that can access websites from the command line, and this is what we will use to extract the data from Yahoo Finance. So we go into the Docker file, and here we see what gets installed here, and here we need to additionally install also the curl library. And we also need to install the SSL certificates because we want to use the HTTPS protocol to access the sites. Since it's rather lengthy, I just copy here what I've already done. So we need to add here additionally the SSL library, and then we need to additionally run here the curl command. This is how curl basically on their website say that you should install it, and that is exactly how we do it, and we use here the with OpenSSL flag to actually also have the HTTPS protocol available. Afterwards we need to rebuild the Docker, and then we can access curl in the source code. Based on a sample module that is already in the framework, we will now build the curl wrapper. So we will copy the sample module, rename all the files, and basically use it as a template for the curl wrapper. So let's do that. Additionally, we need to add curl in our build system that it actually gets used, and that's what I will do here in this meson build file. Because I'm lazy, we will implement everything as a header only, so we can get rid of the CPP file and basically only implement everything in the HPP file. In your projects, you should not do that, but here I'm just, as I said, I am lazy and I want to be fast. This curl wrapper is relatively straightforward. Since curl is already a C library, we can use the C functions of curl and wrap them inside an object-oriented approach to generate an object that can then later be reused in the rest of the code. So we start by including curl and by setting up the initialization in the constructor and the destruction in the destructor of the object that is given by the library, and I just show how it goes. The library requires to have basically a handler what they should do with the request, and they need also to have a function where they can access the object where they need to write whatever they are extracting from the web page. And this is done by using the setup function of curl, and this we will use to implement the curl handler to append whatever we read out from the web page to some string inside of our class here. So we will set up a string and set up the handler, which is then writing the data into the string. The syntax of this API is basically given by the library itself, so I just know how it looks like. And since it's a C library, they always use char pointers for whatever data they get. And here we use the char data then to write the content that we get and append it to the string that we already have inside of our user data. Now let's use that to actually download some data by a given URL. That's already it. We have set up here our URL, converted it to a C string, and then we basically tell the library, the curl library, to perform whatever we have set up. So here in the constructor, we have already set up where to write data, and here we have given it the URL where it needs to access the data. The last thing that we need to do is to create the correct URL from which we want to read the data. And this is where we will use basically the access to the Yahoo Finance database, because they have nice CSV data of stock market. So let's do that. So working with Chrono is always a little bit of a pain. I think since C++20 actually it got much better, but it's still a lot of namespace stuff. That's why I usually use the namespace. I know it's a header file, and I know you shouldn't use namespace in header files, but I know what I'm doing here, and I just say that don't do this in header files, and I'm doing it anyways. So. This is the interface to the function. So we have the symbol, which is basically the stock symbol that we want to download. Then we have the first date, we have the second date, and also the interval of the data that we want to download and create a CSV for. So we will use here the time points of the dates to create the string that needs to go into the URL. And then we will just attach the URL. Since it's kind of lengthy code for the URL, I will just copy paste it. So here we're basically taking the timestamp, the Unix timestamp since the beginning of the epoch, which is also required by the Yahoo interface. And we're putting it into the date 1, into the date 2. And here in the string, we're basically only setting up here the query to the Yahoo Finance. And here we're inserting the symbol. Then we're inserting the first date, we're inserting the second date, the interval, and also what data we want to read out. What you should always do with your code is writing tests. So I've written here now in the curl wrapper test class or file, I have written 2 tests. One test for the URL generation and one test to test the complete wrapper, where I'm reading out the URL. And basically what I'm doing here is I create a wrapper object, And then here I'm generating one time the URL where I know what the real URL should be, and basically comparing if this is the same. And I also generate here a complete query by generating the URL and then downloading the CSV file and checking out whether the response that I get here is actually this string, and I know that this string is correct. So let's run the code against those tests and see whether it passes. To run the tests, we simply go back to the console and use here the test alias, which is also in the README. And here we just use the curl wrapper test and test whether this actually does work. The compilation of this might take a while, so you can also create an extra test test.c for that, as described in the catch docu. The tests are a bit based on Catch 2, which is a great testing framework for unit testing code. So if you don't know it, have a look, check it out. And here we already see some things. So first of all, we have a warning, non-void function doesn't return a value. Apparently there's something wrong in the code. And we also apparently have here some seg fault. And the test is failing. So at least we know now something. Let's go back here. Apparently here in line 36. We should obviously return the URL. And then let's rerun the test. And now the test passes, so the seg fault was because we weren't returning something. And here we do have two assertions in two test cases, which means that these two test cases here with the URL generation and the test curl wrapper, they do pass. So we get the correct URL on the first hand, and on the second hand, we get the correct data that we would expect by passing the URL into the curl string. So our web scraper is already finished. The next step is to build a CSV parser for the spot data. The spot data is basically what comes back from the call, which is the date, the open values, the high values, low and close. And these are now the data that we want to parse out of the CSV file. So we will also start again with a sample module, create the spot parser module out of that, and use this string here to extract the data out of the string. Okay, we have created an empty spot data class, and the spot data class will now use the CSV file to extract the data, and we will create a struct which contains the data, and then we will create a map which uses the time point as the index, and then the trading data for that particular date as the value of the map, which will later allow us to easily handle the values and also to access values for different dates. Pass the data of the CSV file, we will use a string stream, and then we will walk line by line through the string stream, and for each of the line we will use a regex expression to split the string at the comma which is separating the values. use here the standard get line because the standard get line will get rid of the first line, and the first line is only containing the header and no real values for us, so we use it here once before the while to just drop the first line. And then inside the while we will create a regex expression and then use the token iterator, which is a cool thing. The token iterator basically splits the line or a string in this case at the tokens which we give it with a regex expression. The regex itself I will not explain. You can go on any website and check out how these regexes work. Sometimes they're a little bit messy, but they're definitely worth checking out. It looks more scary than it actually is. So here we have now created the vector with the different values at the different entries. And now we just check whether the first few entries are actually there and not null. And if they are not null, then we will put them into our map. So this is something that is really cool. So since C++ 20, I think this part of the date library is already inside the standard. Here, basically, you can use the parse. I think now it's standard parse. But here, because I'm currently using a compiler which doesn't have that implemented, I'm falling back on the original date implementation. But what it basically does is that you can create nice strings and convert them into time points, or you can take time points and convert them into strings. And here in that case, we actually want to get the correct time point out of the string that we get read out from the web page. So in the CSV file, there's a string which has basically the date encoded. And here we say that the encoding is %f, which means there's like the specific, the year, the month, and so forth. And we want to create a time point out of that. Previously, this was a big hassle without the date library. Today, with the date library or with the C++ 20 standard to come, this is really something that got a lot easier. The last step is that we need to create the trading values and put them into our map. And here we will use the new function that is also in the standard to create a double based on the string that we read out. So let's do that. And here we're already done. The test for this is relatively straightforward. So we only check the CSV parsing. So we use the string that we already had from the other test. And we know what values are inside here. And we want to use here the spot data to parse those values. And here we see, or we know that the values, for instance, on December 30, 2022, the high value needs to be this value. If this is the case, then we have succeeded in parsing the data. So let's head to the console, compile this, and see that the test actually passes. So it seems there are a few problems, looks worse than it actually is. So here in the trading values, we're missing here the semicolon, and this one here was previously private. So let's rerun the test and see how it looks now. So after fixing a few typos, we can run the test here in the console, and now everything should be passing. And here we are. So all the tests are passing. So the CSV data is read out as we expect. So let's head over to the fun part. This is where we create the input, so the dates and the stocks which we want to actually show. Inside this update function here, we do have currently the demo window implemented. This is what you saw at the beginning. And here we need to implement our stuff to basically do the buttons, the input tags, and later on also the graph of the data. So we start by implementing here the ImGui for the graph and also for the input data. For the input data, we will create 2 text fields for the dates and 1 button that we click on where we then actually send the request to the server, and also 1 text input field for the symbol of the stock that we want to read out. Okay, let's go. This is something that you should always do. So it's an early out basically in ImGui. So in case this GUI is collapsed, we do not do any of the other stuff and directly early out will save some CPU load along the lines. Important here is that usually we won't hit that, but anyways, it's good practice. So I use some good default values here for the starting date, which is the 1st of January, ending date, which is today as I do this video, and for the symbol I chose to show the S&P 500 index. Here as a last step, I have introduced here a button, and super cool in Dear ImGui, I can just use here the if to see whether it has been pressed, and if this is the case, I call the function parse data, which will then actually reuse the values that have been input here and basically send the request to the server with the curl wrapper and the spot data that we have written before. It's already it with the parse data. For the beginning, since we already have some default values, it makes sense to also call the parse data function at the beginning of the startup, and not only as the button is pressed. So actually at the beginning, directly after starting the application, we already have some sensible values. So let's also put the parse data in the startup function. So let's head over to the console and use the build command to build it. And after fixing, I think, one or two compile issues, we will be able to run the application. And here already linked, and if we fire it up, this is how it looks like. So here we have the stock market graph, and here we have the input data and this part input button, and it's already pre-filled here with the default values. Now we get to the fun part. The fun part is creating a graph out of the data. So in stock markets, one very common graph is the so-called candlestick chart. So you basically have the open and the close values, and then also the high and the low values, whereas the open and the close values, they are as a rectangle, and the high and the low values, they are like a line basically going through the rectangle to indicate how high and how low the stock market has gone in that day. Also, since we're a little bit fancy, we want to paint them in green if the stock is going up, and we want to paint them in red if the stock has been going down that day. So what we need here to do is to write our own plot, and I use the ImPlot library for that. But since the type of chart that we want to have is not inside the library, we need to do a few extensions, or we need to basically integrate this kind of plot into the ImPlot library, which is also something that is not super hard to do, but is a little bit more effort than just taking any graph out of the library and using it. So yeah, what we need to do is we need to create the plot, we need to set up the axis, and then we need to basically fill the rectangles, and we need to fill then also the candles. Okay, let's do that. Here we're setting up the axis. We say that we want to have the date and the value, and we also say the format of the axis, and we also say that the x-axis should have here as a scale time, and the time here is again in the Unix timestamp, and here ImPlot is automatically understanding and then putting the dates for us in the correct fashion, and we only need to pass the Unix timestamp, which is pretty cool for us because we already have the Unix timestamps available. So what we will need quite often here is a function which I now have named conf, and this is something that we will implement as a lambda function because we will need it quite a few times across this code. And what it does is basically taking here the time point, which is basically here the starting iterator, is the beginning of the spot data that we have. And here the first indicates that it's the key, so it's the timestamp of the first data sample that we have. And here this timestamp is something that we want to convert, and we want to convert it into the Unix timestamp. And that's why we will use this conf lambda, and the conf lambda will be used quite a lot, and that's why we implement it like that. The next thing is the half width. This is basically, given the data samples that we have, it is the width of each of the rectangles that we want to paint. So what we need here is we need to figure out the distance between the first and the second data sample. And if we have this distance, then we can use this as then we can use this to scale the half width. We only do this if we actually have more than a single data sample, because otherwise it just doesn't make sense. And if we do that, then we can later use the half width to calculate how big the rectangles need to be. As a next step, we will iterate through all the spot data and generate the correct positions and the correct rectangles. This is basically done by using here the half width and then the open and close values. And we will again use here something, or we will use something that is called a structure binding. So since we want to have here open and close values, it does make sense to go through a complete list of the spot data, and this is how it looks like. So since I think a few C++ versions, you can actually extract out of the spot data the key and the value, and basically in one pass in a for loop, which is kind of very cool for this endeavor here, because here we can use then the key and the value both in the same for loop without needing to extract it somehow else. What we do here is we calculate the position of the open, close, low and high. Basically the open is the key and the open, the close is the key and the close with a little bit more. The low position is the low and the high. And here we also calculate the color, since we want to have a green rectangle if it's going up and we want to have a red color if it's going down. And then we just point or add something to the draw list, which we need to create here a line and a full rectangle. The draw list is something I think that is still missing. This is something that you can always just read out from the framework by using the pointer. So let's also do that here. We will do it directly at the beginning because we don't want to do it every single time in the for loop. So let's do it here. We have now already painted all the data. Because it's a custom plot, what we still need to do is what means to fit the data. So usually ImPlot, and this is also what we have here, it has the option to fit the data completely onto the screen. And now we need to tell ImPlot basically what this means in case of the data that we give it here. So we still need to implement this function, what it means if it's fit to frame. Here we basically choose the lowest and the highest values. So we ignore the open and the close values because the lowest and the highest values, they are far apart, and we also want to show them into the screen if the fit to frame function of ImPlot is being called. Okay, let's build. After fixing also a few minor typos, it should now work. Going in here, compile the application, and then we can run it by using the run command. And this is what we get. So here we have the stock market graph, we have here the input data, and this is basically the candlestick chart for the S&P 500 since beginning of this year. We can also put here different times, so we can also say that we want to see data beginning last year, and then parse the input, and then we see that we have already lost quite a bit since then. Or we can also go to some different symbols. So of course you need to know the symbol name. But for instance, we can go here and put the data for the Tesla stock, or for any other stock that you might be interested in, like Google, like Facebook, or whatever. So yeah, thanks for joining me here on this ride. We are able to read out data from the internet. We're able to parse the CSV data, and afterwards to plot it in a nice graph and see how our stocks are developing. I hope you have learned something along the way. I hope also that you have enjoyed the content. If you do, leave a comment below what is best for you. And other than that, and as always, enjoy coding.